All right, so after a short break from Physics 1, we're back at it with Physics 2, starting off with Lab 1, charge tapes. So what is this lab all about? Well, the main purpose of this lab is to observe the interactions that occur between two electrically charged pieces of tape. And from these interactions, we want to determine how much excess charge has accumulated on each of these tapes. Now the materials we will use is, of course, clear tape, ruler, flat surface, and objects to support the tape. We will also be using GlowScript as a computational model to simulate the tape and interacting forces. Now just a quick brief overview of the results which we will be seeing is that the charge on each tape was determined to be this, and the number of electrons lost by each tape was determined to be this. Before we jump into the lab, let's talk about some fundamental physics principles we need to know. First up is our beloved Newton's second law, which states that a system's change in momentum is proportional to the net force applied to it. Or in simpler terms, force is equal to mass times acceleration. Next up is Coulomb's law, which describes the force of attraction or repulsion between two electrically charged objects. And last up is the gravitational force, which can describe the attractive force between any two objects that have a mass. The first thing I need to figure out in this lab is whether the pieces of tape I'll be using are electrically negative or positive. To determine this, as you can see in the first video, I'm going to take a piece of tape and tape it down on another piece of tape that was already taped down to the table. Try saying that 10 times fast. Then I'm going to rip off that top piece of tape and make it electric charged. Well, is this going to be negatively or positively charged? Well, to figure this out, I'm going to use a pen that I know for sure is negatively charged from rubbing it with wool. And I'm going to bring it close to that piece of tape. And as you can see, it attracts it. It almost sticks together too. So that must mean that the tape is electrically positive. There you go. Because we know like charges repel, what I did next was float one positively charged piece of tape on top of another positively charged piece of tape. And I measured the distance between them to be 0.025 meters. Now, in this specific example, tape B was to be my system, and tape A and everything else was my surroundings which acted upon the system. And tape B was the one that actually was able to flow. Now, the main objective of this lab was to actually calculate the amount of excess electrons that were removed from the positively charged piece of tape. Well, this requires us to go through four main steps. First up, let's consider the gravitational force that acts upon our system, which was tape B. Well, that's just equal to its mass times the gravitational acceleration. Next up, let's consider the system's free body diagram. Well, we know that tape B is floating and stationary, so that must mean that the net force on it should also be zero. Well, that means that the electric force from charge A, or tape A, acting upon tape B should equal in magnitude of that of the gravitational force of tape B. Well, there you go. Now, using this and using the electric force equation, we can figure out that the charge is this number. Now, we need to figure out how many electrons were lost. So, by taking the charge of the tape and dividing it by the absolute value of the charge of an electron, we can determine that there were exactly 7 times 10 to the 10 electrons that were lost in this process. Well, taking the ratio, all this means is that for every 5.7 times 10 to the 6 atoms, 1 electron was lost. Next up is the computational model in GlowScript, and this serves as an ideal representation of the experimental procedures that just occurred. I've highlighted the important parts in yellow and blue, and as you can see, the charge of the piece of tape and the ratio were able to be accurately calculated. In our model, we had to make a few assumptions to make the computation more bearable. And these included assuming that the air resistance and friction were negligible, that the long piece of tape could be treated as a point charge at the center of the tape, and that each piece of tape had the same amount of charge evenly distributed throughout. Well, we know that these assumptions would of course cause some errors throughout the actual experimentation, because we know that there's going to be some unequal distribution of charge along the tape, and that since we use our hands to handle it, there's going to be some loss of charge due to handling or to the environment. Alright, let's have a deeper dive into the results and have a bit of a discussion. First up, what if electrons and protons had inverse charges? In other words, what if electrons were now positively charged and protons negatively? Well, actually, nothing changes. All the observations made throughout the lab would remain exactly the same. Well, why is this? Although the charged pieces of tapes would now be considered negatively charged, they would still repel each other, and this is because like charges always repel. Next up, why is it important to handle the tape as little as possible? Well, the charged tapes begin to neutralize when they come into contact with our hands or some other objects in their environment. And this is because they're trying to gain back those electrons that they lost in the first place. Remember how the tape is positively charged? Well, when they come into contact with our hands, they're trying to gain those electrons from our hands to become back to neutral. And that's a wrap for our first lab. Thanks for your attention.